Hello everyone, in this video we're going to review unit set of AB, calculus, AB and BC. Question 1. Alright, consider the function y equals 4s minus s squared. Question A. Sketch the curve y equals 4s minus s squared. Alright, so this one actually the quadratic equation, right? So we're going to rewrite this one as negative s squared plus 4s, right? And you see that a is -1 less than 0. The quadratic function is concave double, right? And the axis symmetry is s equals negative b over 2a, right? So it could be negative 4 over 2, negative 1, and it's going to be 2, right? So this one is the axis symmetry. Now we need to find the vertex, right? So substitute 2 for s back to the equation right here, right? So we have y of 2 equals 4, right? So it's going to be right here is the vertex. Now we need to find the 0, right? So we're going to let y equals 0 to solve for s, right? So we have 4s minus s squared equals 0, right? Factor s out, so it could be 4 minus s equals 0, right? So s equal to 0 and s equal to 4, right? So it could be right here and right here. Now we just connect this guy and it's going to be parabola. Now question B. Show the regions that represent the area of the regions enclosed by y equals 4s minus s squared and the x-axis. So it's going to be something like this. Question C. Write the definite interval that represents the area of the region enclosed by y equals 4s minus s squared and the x-axis. So it could be the interval from 0 to 4, right? From here to here. Of 4s minus s squared ds. That's it, right? Now question D. Use the left sums to approximate the interval found in part C on the interval 0 to 4 using 4 subintervals, right? So we need to find the width, right? The width is going to be delta s equals b minus a over n. This one is A, this one is B, and N is equals 4. So it's going to be 1, right? The error using the left Riemann sum is going to be the interval from 0 to 4 of 4s minus s squared ds is. Now we're going to sketch the number line. This one is 0. This one is 4, right? And you have 4 subintervals, right? So this one is 2, this one is 1, and this one is 3, right? Now since you're going to use left Riemann sum, so you're going to use this guy, this guy, this guy, and this guy only. And delta s is right here. It's going to be 1, right? So you have 4 times 0 minus 0 squared. This one is the height, right? Substitute 0 for s over here to find the height, right? Times the width is going to be 1. We finished the first one. Plus the second height right here. Substitute 1 for s into this expression right here. So you have 4 times 1 minus 1 square times 1, right? The third one is going to be 4 times 2 minus 2 square times 1, right? And the last one plus 4 times 3 minus 3 square altogether times 1, right? Now if you simplify this one, it turns out to be 10. This one is the final answer, right? Question E. Use the midpoint rule to approximate the interval from 0 to z of this guy using 3 subintervals, right? Now we're gonna sketch the number line. This one is 0, this one is z. We need 3 subintervals only, right? So we're gonna split this one into 3 subintervals, 1, 2, and 3, right? So this guy should be 2 and this guy should be 4, right? And delta s actually 2, right? It's gonna be 6 minus 0 divided by 3. It's gonna be 2, right? This one is b, this one is a, and n equals 3. Substitute into this formula right here. We get delta s equals 2, right? Now, since this one is the midpoint, right? The midpoint right here, this one should be 1, this one should be 3, and this one should be 5. So we're going to use these values of s right here, right? So we have a midpoint equals the interval from 0 to z of 4s minus s squared ds, right? Equals. Now substitute 1 for s into this expression right here to find the height, right? So we have 4 times 1 minus 1 squared, right? Times the width is 2 right here. Plus the second one, 4 times 3 minus 3 squared times 2. Plus 4 times 5 minus 5 squared times 2, right? Now if you simplify this one, the answer must be 2. Question 2. The rate at which a wheel is turning is given by a differentiable function r, revolutions per minute, right? Because this one is the rate, so you have per minute of time t minutes. The table to the right shows the rate as measured every 3 minutes for 12-minute period. Use a right sum width for intervals to approximate the interval from 0 to 12 of r t dt. Using correct units, specifically explain the meaning of your answer in terms of the motion of the wheel, right? We see that we have 4 subintervals, right? So this one is the first interval, this one is the second interval, this one is the third, and this one is the last one, right? The width is 3, the width is 3, and 3, and 3, right? Now, using the right, so we're gonna pick the right one, which is this guy right here, right? So we have the interval from 0 to 12 r of t dt equals, now length times width, right? So we have r of 3, right? This one is the height, and then times the width is 3 right here. So times 3 plus r of 6 times 3 plus r of 9 times 3 plus r of 12 times 3, right? Now I'm going to factor 3 out, right? So I have 3 times r3 equals 5 right here, right? Plus r of 6 equals 5 plus r of 9 equals 10. And the last one, r of 12 equals 20, right? And the final answer must be 120. Now, since this one is the rate, when you take antiderivative of the rate, there's no more per minute. The unit should be revolution only, so keep that in mind. Now, let's move on to question 3. If f of s equals the antiderivative of f of s ds, and given this guy and this guy, we need to find the integral form phi of ls ds. Now keep in mind, when we see the lower limit and upper limit are the same, the answer must be 0, right? Now question B. If you see the lower limit is greater than upper limit, you need to flip the upper and lower bounds, right? So it turns out to be integral from 4 to 5 of f of s ds. Don't forget to put the negative sign in front, right? Now integral from 4 to 5, it turns out to be 14 right here, so the answer must be negative 14, right? Now question C. The integral from 2 to 4 of f of s ds. Now look at this one, it's not given, right? So we have 2 to 5 and 4 to 5, right? So we can rewrite this one as the integral from 2 to 5 of f of s ds equals, we're going to put 4 in the middle right here, right? So we have the integral from 2 to 4 of f of s ds plus the integral from 4 to 5 of f of s ds, right? Now the integral from 2 to 4 equals this guy right here, subtract this guy, right? So it's going to be the integral from 2 to 5 of f of s ds, subtract integral from 4 to 5 of f of s ds, right? Now we just substitute the value. This guy equals 6 and this guy equals 14, right? So the answer is negative 8, right? Now question D. The integral from 2 to 5 of 3 times ls ds, so it could be 3 times the integral from 2 to 5 of f of s ds, right? It's going to be 3 times 6 right here. It's going to be 18, right? Now question E. We can split this guy, right? So it turns out to be the integral from 2 to 5 of f of s ds plus the integral from 2 to 5 of 2 ds, right? So this guy turns out to be 6 plus, now this guy right here, actually, if you write this one, it's going to be like this. Y equal 2 right here, right? This is from 2 to 5, right? So you have the width right here is 3, right? The height right here is 2, right? So actually this one is the area of the rectangle right here. 2 times 3, right? So it could be 2 times 3 and the answer is 12. Now question 7. So it turns out to be the integral from 7 minus 2 and this is 4 minus 2, right? And then this guy turns out to be f of s ds, right? So it's going to be integral from 2 to 5 of f of s ds, right? And it's going to be 6. Now question 4. The table below lists the measurements of a lot bounded by a stream and 2 straight roads that meet a right angle. So we're going to sketch this one. It's going to be something like this, right? This one is the road and this one is the another road, right? And you have the stream. It's going to be something like this. This one is the stream, right? Now estimate the area of the lot using left endpoint sums where n equals 6, right? So we have this one is A, this one is B. So we see that every single width equals 50, right? Now we have the area using the left Riemann sum. It's gonna be, we're gonna use this guy, this guy, this guy, this guy, this guy, and this guy, right? N equals 6, and then left Riemann sum, right? So we have the height is 450 right here, times the width is going to be 50, right? Plus the second height right here, 362 times 50. The width doesn't change, right? Next one, plus 305 times 50, plus 268 times 50, right? Plus 245 times 50. And the last one, plus 156 times 50, right? If you use a calculator, the answer must be 89,300 square feet, right? Now question B. Estimate the error of the lot using the right endpoint somewhere n equals it. Now we do exactly the same thing, right? So the error using the right Riemann sum, right? So in this situation, we're going to use 50, 100, 150, 200, and 250, right? So we have the height is going to be 362 plus 305 plus 268 plus 245 plus 156, and the last one should be 0, right? And then all together multiply by width. The width is going to be 50, right? Now the answer must be 66,800 square feet. Now let's move on to question C. Estimate the error of the lot using the midpoint rule where n equals 3. So you see that we have 3 subintervals. It's going to be from here to here, right? And this one from here to here. And this one from here to here, right? Now you're going to use the midpoint, so it's going to be this guy right here, right? So you have the error using the midpoint. It's going to be the height is 362 plus 268 plus 156, and then multiply by the width is going to be 100. They are the same width, right? So the answer must be 78,600 square feet. Now let's move on to question 5. The graph of f is given in the figure to the right. Evaluate the interval from 1 to 7 of fs ds. Alright, so we're going to use the geometric figures to calculate the error, right? So it's going to be from 1 to 7 right here, right? And you know that this one is the trapezoid, this one is the another trapezoid, this one is another trapezoid, and the last one should be rectangle, right? So the trapezoid here has the height 1, right? And the base is going to be 1 and 3 right here, right? So you have base 1 is going to be 1 plus base 2 is going to be 3 times the height is going to be 1 divided by 2. Now the second one, the height is 1, right? And the base is 1 and 2, right? So it could be plus 1 plus 2 times 1 divided by 2. The first one, the height is 1. The base is still 1 right here, and the base still 2 right here, right? So this guy and this guy technically the same, right? So I just multiply by 2. And the last one, this one, the length is 7, subtract 4 is going to be 3. The width is going to be 1, right? So it could be plus 3 times 1, right? So if you simplify, the answer must be 8. Now question B. Determine the answer if average is translated 2 units upward. Alright, so it's the same thing as the interval from 1 to 7 of f of s plus 2 ds, right? Turns out to be the integral from 1 to 7 of f of s ds plus the integral from 1 to 7 of 2 ds, right? Now this one already calculated above, it's going to be 8, right? Plus, now for this one, it's actually the area of rectangle from 1 to 7, right? So the length is going to be 7 minus 1 is going to be 6. The width is going to be 2, right? So it could be 2 times 6, right? And it's going to be 20. Now question 6. Use the trapezoid rule to approximate the following definite interval. Write the answer to the nearest thousands. Right? This one is the trapezoid, right? So remember, the area of the trapezoid is base 1 plus base 2 times height divided by 2, right? Now we have 4 subintervals, right? So we have delta S equals b minus a, b equals 5, a equals 1, right? So 5 minus 1 divided by 4 is going to be 1. So delta S equals 1, which is the height. So we have the integral from 1 to 5 of s square root of 2s plus 1 ds equals. Now we're going to draw the number line. This one is 1, this one is 5, right? You have 4 subintervals right here, and each subinterval has the width 1, right? So the first two base is f of 1 and f of 2, right? So you substitute 1 for s right here. It's going to be 1 square root of 2 times 1 plus 1, right? And the base 2 is going to be 2 right here. So it could be 2 square root of 2 times 2 plus 1, right? All together times the height, which is 1, divided by 2, right? The second one is going to be from 2 to 3, right? So you have 2 square root of 2 times 2 plus 1 plus 3 square root of 2 times 3 plus 1 times the height is going to be 1 divided by 2, right? Next one from 3 to 4. So you have plus the first height is going to be 3 square root of 2 times 3 plus 1 plus 4 square root of 2 times 4 plus 1 times the height is going to be 1 divided by 2. And the last one from 4 to 5, right? So it's going to be plus 4 square root of 2 times 4 plus 1 plus 5 square root of 2 times 5 plus 1 times height divided by 2, right? Now if you simplify this one, the answer should be approximately 33.567. Now let's move on to question 7. For the following measurements, each are in feet made across the leg shown. Use the trapezoid rule to approximate the area of the leg. Write the answer to the nearest square foot. Alright, so the area using the trapezoid rule, it's going to be base 1 plus base 2 times the height divided by 2. You see that the height always equals 25, right? This one right here, the height always 25, 25. Now we start from here. So we have 0 plus 22, right? Divided by 2. All together, I'm going to multiply by the height outside because we have the same height. We just factor 25 out, right? Plus the second one, 22 plus 32 divided by 2, right? The second height right here and the third height right here, right? Now the third height and the fourth height right here, plus 32 plus 30 divided by 2, right? And that's 30 and 42, right? Plus 30 plus 42 divided by 2 plus 42 plus 36 divided by 2. And finally, 36 plus 0, right? Divided by 2, right? Altogether multiplied by 25. If you use a calculator, the answer must be approximately 4,050 square feet. Now question 8. Consider the graph of a continuous function f(s) given to the right. Approximate the interval from 0 to 10 of f(s) ds using trapezoid rule with n equals 5, right? So we start from here, we end right here. N equals 5, we use the delta s, it could be b minus a divided by n, right? So it could be 10 minus 0 divided by 5, it could be 2, right? So it could be 2, 4, 6, 8, right? Now this one is a trapezoid, right? So you have the error using the trapezoid. It's gonna be base 1 right here, it's gonna be 5, and base 2 right here, it's gonna be 8. 5 plus 8 divided by 2 times the height should be 2, right? So I'm gonna put 2 outside, right? I factor 2 outside, plus next one, the base is right here and right here, so this is about 9.5, right? So you have 8 plus 9.5 divided by 2. Next one, 9.5 plus 7 right here, right? 9.5 plus 7 divided by 2. Next, 7 plus this guy 1, right? 7 plus 1 divided by 2. And the last one, 1 plus 2, right? 1 plus 2 divided by 2, and altogether multiplied by 2. Now if you use the calculator, it's approximately 57. Question B. Approximate the interval from 0 to 8 using the midpoint rule where n equals 4. So you have delta s is going to be 8 subtract 0 divided by 4 is going to be 2, right? So 0 right here and 8 right here. The width is 2, so it could be 1, 2, 3, and 4, right? So you have 4 subinterval. Now, this one is the midpoint, right? So you have, remember, we're going to use the midpoint rule. Make sure the midpoint should be on the graph, so it could be right here, 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 and here. Now we're going to have the error using the midpoint, right? It's going to be length times width, right? The width always 2, right? The length is going to be the height right here, right? So it could be f of 1, f of 3, f of 5, and f of 7, right? So it could be f of 1 equals 6 right here, right? So you have 6 times 2 plus f of 3 equals 9 right here. 9 times 2 plus f of 5 equals 9. So it's going to be 9 times 2 plus f of 7 equals 4 right here. So 4 times 2 equals 56. Now let's move on to question C. Approximate the interval from 0 to 10 of f(s) ds using the left side rectangles with n equals 5. So we have delta s equals 10 minus 0 divided by 5 is going to be 2, right? So we have, alright, so the error using the left side rectangles is going to be length times width, right? The length is 5 right here. Times width is going to be 2, right? Next one, the length right here is going to be 8. Plus 8 times 2 plus the next one right here, so it could be 9.5 times 2 plus this guy right here, it should be 7 times 2, and this guy right here, it should be 1, right? 1 times 2 equals 61. Now let's move on to question 9. Due to a bad storm on a low-lying road, a large circular puddle of a water forms. The area of the puddle increases as a storm intensifies. The radius of the puddle in feet is modeled by the twice differentiable function R of t, where t is measured in minutes. For t from 0 to 15, the graph of R is concave up. The table below gives selected values of the rate of change or parameters of the radius of the puddle over the time interval from 0 to 15. The radius of the puddle is 7 feet when t equals 6. Now question 8. Use a right Riemann sum with 6 intervals, which means n equals 6. Alright, so since n equals 6, right, so we need to find the width. It's going to be 3, right? This one should be 3. This guy should be 2. This guy should be 3. This guy should be 1. And this guy should be 3, right? Now, the right Riemann sum, which means we're going to pick the height. It's going to be right here. Right? So we have the error using the right Riemann sum. It's going to be length times width, right? So we have 2.3 times 3 right here, plus 3.4 times 3, plus 4.3 times 2, plus 4.9 times 3, plus 5 times 1 right here, and the last one plus 6.2 times 3. So the answer must be 54 feet. Question B. We do exactly the same thing, but we're going to use the left Riemann sum, right? So we have A left equals. So left Riemann sum, we're going to use this guy right here. 1.2, 2.3, 3.4, 4.3, 4.9, and 5 only, right? So we have 1.2 times 3 plus 2.3 times 3 plus 3.4 times 2 plus 4.3 times 3 plus 4.9 times 1 plus 5.0 times 3. And the answer is 50.1 feet. Now, question C. We do exactly the same thing, but we're going to use the trapezoidal sum, right? So remember, trapezoid error is going to be base 1 plus base 2 times height divided by 2, right? Now, we go back over here. Base 1 is 1.2 and 2.3, and the height should be 3, right? Base 1 is 2.3 and 3.4, and the height should be 3, right? The next trapezoid, base 1 is 3.4 and base 2 is 4.3, the height should be 2. Next one, base 1 is 4.3, base 2 is 4.9, and the height should be 3, right? Next, base 1 is 4.9, base 2 is 5, and the height should be 1. The last one, base 1 is 5, base 2 is 6.2, and the height should be 3, right? And the answer is approximately 57.05 feet. Now let's move on to question D. Use a midpoint sum with 3 intervals. Alright, so we're gonna go back over here. The midpoint sum with 3 intervals. So the first interval is gonna be from 0 to 6. Second interval should be from 6 to 11. And the third one should be from 11 to 15. Now the width is gonna be 6. This guy should be 5. And this guy should be 4. Right? Now since we use the midpoint, so we need to use this guy right here. 2.3, 4.3, and 5. Right? So it will be length times width. That's it, right? 2.3 times 6, 4.3 times 5, and 5 times 4. And the answer is 55.3 feet. Now question E. Use correct units. Explain the meaning of this interval in the context of the problem situation. So we need to say that the interval from 0 to 15 r prime of t dt gives the total amount, the radius of the total changes from time t equals 0 to t equals 15 minutes. Now let's move on to the second part of the unit 6. We need to find the integration of logarithmic, exponential, and inverse trigonometric functions. Now question 1. We need to find the antiderivative of 1 over s ln s squared ds. Alright, so we look at this one. We have two expressions right here. The first one is going to be ln s squared, and the second one is going to be s, right? This one is more complicated, so we're going to let this one be u, right? So we let u be ln s squared, right? And we use the formula derivative of ln of u. It's going to be u prime over u, right? So we have du equals 2s over s squared ds, right? And then if we simplify, it's going to be 2 over s ds, right? So we look at this one, we see that 1 over s right here, we need to multiply the top and bottom by 2, like that, right? So we're going to replace 2 over s ds with du, right? So this guy turns out to be the antiderivative of du over u. Don't forget to multiply by 1/2, right? Then the antiderivative of du over u is going to be ln absolute value of u, right? Plus c. Don't forget 1/2 here. Now we need to replace u with s, right? Because we need to go back to the original one, right? So it can be 1/2 ln of absolute value of u, but u equal this one right here, right? So it can be ln of s squared plus c, right? Now question 2. We see that we have two expressions right here, 1 and 2 right here. This one more complicated, right? So we're going to let this one be u, right? So we have u equals 1 plus cube root of s, right? And this guy turns out to be u equals 1 plus s power 1/3, right? Now we take the derivative, we use the power rule, right? So du equals 1 over 3s power of -2/3, right? ds. And this guy turns out to be 3 du equals ds over s power 2/3, right? So we replace this guy right here with 3 du, right? So this guy turns out to be the antiderivative of 3 du over u, right? So it can be 3 ln absolute value of u plus c, and it's going to be 3 ln of absolute value of 1 plus cube root of s plus c, right? Now question 3. We look at this one right here. We see that the variable is theta. This one is phi theta, right? So we let this one be u, right? So we have u equals phi theta, and then du equals phi d theta, right? Now we only have d theta right here, so we need to multiply by phi and divide by phi, right? Like that. So this guy turns out to be 1 over phi antiderivative of cosecant u du, right? And it's going to be negative 1 over phi natural log of absolute value of cosecant u plus cotangent u plus c using the formula, right? Now we substitute as fast, so it can be negative 1 over phi ln absolute value of cosecant phi theta plus cotangent phi theta plus c, right? Now let's move on to question 4. We look at this one, we see that there's a two expression right here, right? This one more complicated. We let u be this one, right? So we have u equals ln cosine s, and then du is going to be, we're going to use the formula ln of u prime is going to be u prime over u, right? So u prime, which means cosine prime, is going to be negative sine s over cosine s ds, right? But negative sine s over cosine s is going to be negative tangent s ds, right? So I'm going to multiply both sides by negative 1. So it can be negative du equal positive this one, right? So this guy turns out to be 2 times negative du, right? So I put du right here and I put negative side right here, right? And I have u right here because u equal this one, right? So this guy turns out to be negative 2 times u squared over 2 plus c, right? And negative 2 and 2 cancel out, right? So I have negative u squared, but u equal this one, so it can be ln square of cosine s plus c, right? Now question 5. This one is the rational function where degree on the numerator is greater than degree on the denominator. We need to do long division, right? We're going to take s cubed minus 3s divided by s squared minus 1, right? So s cubed divided by s squared is going to be s multiplied by is going to be s cubed minus s subtract is going to be negative 2s, right? So this guy can be written as antiderivative of s minus 2s over s squared minus 1 ds, right? Now antiderivative of s is going to be s squared over 2, right? If you take derivative of the bottom and you get the top, so we have the formula antiderivative of u prime over u du. It's going to be ln absolute value of the bottom, which means u right here plus c, right? So this one turns out to be negative ln absolute value of s squared minus 1 plus c, right? Now question 6. We have two expressions right here, right? So we let u be this one right here, right? So u equals square root of s, and then du equals 1 over 2 square root of s ds, right? So I don't have 1/2 right here, right? So I multiply both sides by 2. So this guy turns out to be 2 du equals ds over square root of s, right? Now this guy turns out to be 2 antiderivative of e to the u du, right? And it could be 2e to the u plus c, and it could be 2e to the square root of s plus c, right? Now let's move on to question 7. We're gonna let u be s squared, then du equals 2s ds, right? Then we divide both sides by 2, we have 1/2 du equals as ds, right? Substitute back over here, so we have this guy turns out to be 1/2 antiderivative of 3 to the u du, right? Now we're going to use the formula, the antiderivative of a to the s. This one is not power rule, so be careful. It's going to be a to the s over ln of a plus c. So keep that in mind. So this guy turns out to be 1/2 3 to the u over ln 3 plus c. Substitute s squared for u, so it could be 1 over 2 ln 3 times 3 to the s squared plus c, right? Now question 8, we're gonna rewrite this one as antiderivative of ds over square root of 1 minus 2s all together square. Keep that in mind. So we're gonna apply the formula antiderivative of 1 over square root of 1 minus u square du. It's gonna be sine u plus c, right? Now we're gonna let u be 2s, right? Then du equals 2 ds, right? So right here I just multiply the top and bottom by 2, right? So I substitute over here. I have 1/2 antiderivative of du over square root of 1 minus u square. Now I can apply the formula right here. So it could be 1/2 sine u, but u equals 2s, right? So I have 2s plus c. This one is the final answer, right? Now question 9. This guy actually antiderivative of ds over s square root of 9s squared minus 1, right? We can rewrite this one as antiderivative of ds over s square root of 3s all together square. Keep in mind, right? So then we can apply the formula antiderivative of du over u square root of u square minus 1 equals secant of absolute value of u plus c, right? So we let u be 3s, right? Then du equals 3 ds, right? So right here I just multiply the top and bottom by 3. So this guy turns out to be antiderivative of 3ds actually du, right? Now 3 and s right here actually u, right? Square root of u square minus 1. Now I apply the formula right here, so it could be secant of absolute value of u, but u equals 3s right here, so absolute value of 3s plus c, right? Now let's move on to question 10. Observe that if you take derivative of the numerator, it's actually denominator, right? So I'm gonna let u equals tangent s, and then du equals ds over 1 plus s squared, right? This guy right here turns out to be antiderivative of u du, right? And it's gonna be u squared over 2 plus c, and substitute tangent s for u, so it could be tangent square of s over 2 plus c, right? Now let's move on to question 11. Observe that the numerator has the degree less than the denominator, right? So we need to separate this guy. So this guy turns out to be antiderivative of s over s squared plus 9 ds plus antiderivative of 3 over s squared plus 9 ds, right? Now for the first one, observe that if you take derivative of this one, it turns out to be 2s ds, right? So the top is going to be s ds. I just multiply by 2 and I divide by 2, right? So then I'm going to apply the formula antiderivative of u prime over u du. it's going to be ln absolute value of the bottom plus c, right? So this guy turns out to be 1/2, I rewrite it, right? ln absolute value of s squared plus 9, right? Now the second one right here, plus, I rewrite 3. Now for this one right here, remember we have the formula antiderivative of ds over s squared plus a squared equals 1 over a arctangent s over a plus c, right? A in this relation is 3 because 3 squared equals 9, right? So it's going to be 3 times 1 over 3. Remember this 3 right here and right here are the same, right? And 1 over 3 right here comes from the formula right here, right? Because this one is 3 squared, right? Arctangent of s over 3 plus c, right? Now if I simplify, it's going to be 1/2 ln absolute value of s squared plus 9 plus arctangent s over 3 plus c, right? Now question 12. Look at the bottom, we need to make this one as a complete square, right? So I just rewrite this one as antiderivative of ds over square root of negative, factor negative out. So it could be s squared minus 2s minus 8, right? Now I need to make this one as a complete square, right? So this guy turns out to be antiderivative of ds over square root of negative of s squared minus 2s. I'm going to add and subtract 1, right? So I'm going to add 1 right here and subtract 1 and subtract 8. It could be 9, right? So it's going to be antiderivative of ds over square root of negative s minus 1 altogether square minus 9, right? And it's going to be antiderivative of ds over square root of 9 minus s minus 1 altogether square, right? Antiderivative of du over square root of a square minus u square. It's going to be a sine of u over a plus c, right? Now u in this rotation is s minus 1, right? And a in this rotation is 3, right? Because 3 squared equals 9, right? So this guy turns out to be a sine of s minus 1 over 3 plus c. Now let's move on to question 13. Observe that if you take derivative of the denominator right here, it's going to be becomes the numerator right here, right? So we're going to let u equals square root of s squared minus 2s, right? And then I'm going to square both sides, so I have u squared equals s squared minus 2s, right? Take derivative both sides, so it could be 2u du equals 2s minus 2 ds, right? Now I'm going to factor 2 out and divide both sides by 2, so I have u du equals s minus 1 ds, right? Now this guy turns out to be antiderivative of u du over u, right? So it could be antiderivative of du, and this could be u plus c. But u equal this one, so it could be square root of s squared minus 2s plus c, right? Now question 14. Again, I'm going to let u be the bottom, right? So u equals s squared plus 5. And then du equals 2s ds, right? I'm going to divide both sides by 2. So I have 1/2 du equals s ds, right? So I go back over here. This guy turns out to be, I bring 3 to the front, right? antiderivative of s ds, actually 1/2 du, right? So it could be divided by 2 right here, put du right here, right? The bottom actually u, right? So it could be 3.5 ln absolute value of u plus c. But u equal s squared plus 5, so it could be 3.5 ln absolute value of s squared plus 5 plus c, right? Now, question 15. Observe that if you take derivative of the bottom, it turns out to be 2s plus 2, right? On the top, I don't have 2s plus 2, so I need to add and subtract 2, like that, right? So this guy turns out to be 2s plus 2 minus 7, right? So I just separate this in row. It's going to be antiderivative of 2s plus 2 over s squared plus 2s plus 2 ds, right? Minus antiderivative of 7 over s squared plus 2s plus 2 ds, right? Now, we have the formula u prime over u is actually ln absolute value of u plus c, right? So this guy turns out to be ln absolute value of s squared plus 2s plus 2, right? Now this guy right here, we just make a complete square, right? So negative 7 antiderivative of ds over, I'm going to separate 2s 1 plus 1, right? So I have s plus 1 all together square plus 1, right? And then this guy turns out to be ln absolute value of s squared plus 2s plus 2, right? Minus 7 tangent of s plus 1 and then c, right? Now question 16. Observe that if you take derivative of the bottom, it turns out to be 2s plus 6, right? The top is just s plus 3. So if you double this one, right, it turns out to be 2s plus 6. And then when you multiply the top by 2, you need to divide by 2, right? So this guy turns out to be 1/2 antiderivative of 2s plus 6 over s squared plus 6s ds, right? And then it's going to be 1/2 ln of s squared plus 6s. Now since this one is the definite interval from 1 to 3, right? So we put 1 right here, we put 3 right here, and this one should be evaluated from 1 to 3, right? So it's going to be 1/2 ln of, substitute 3 for s, it could be 9 plus 18, it could be 27. Subtract ln of 1 plus 6, it could be 7, right? Now if we simplify this one further, it could be 1/2 ln of 27 divided by 7, right? Observe that this angle is theta over 3. This one is theta, right? So we're going to let u equals theta over 3. And then du equals 1/3 d theta, right? And then 3 du equals theta. Now we need to change the lower bound and upper bound to the new lower bound and upper bound, right? Since we have u equals theta over 3, but theta is from 0 to pi, then u should be from, substitute 0 for theta over here, it's going to be 0. Substitute pi over here, it's going to be pi over 3, right? So the new interval becomes the interval from 0 to pi over 3 tangent of u times 3 du, right? So I put du right here, put 3 in the front, right? Now antiderivative of tangent u is going to be negative ln absolute value of cosine u evaluated from 0 to pi over 3. And don't forget to multiply by 3, right? So it's going to be negative 3 times ln of cosine pi over 3 minus ln of absolute value of cosine 0, right? So it could be negative 3. Cosine of pi over 3 is, now cosine of pi over 3 equals 1 half, right? So it could be ln 1 half minus ln 1, right? Because cosine of 0 equals 1. Negative 3 ln 1 half, right? Because ln 1 equals 0, right? So this guy turns out to be negative 3 ln 1 minus ln 2, right? ln 1 equals 0, right? So the answer should be 3 ln 2. Now let's move on to question 18. We need to use complete square formula, right? So this guy turns out to be the integral from negative 3 to negative 1 ds over s squared plus 6s divided by 2 and square is going to be 9, right? So plus 9 and subtract 9. 13 subtract 9, it should be 4, right? So this guy turns out to be the integral from negative 3 to negative 1 ds over s plus 3 altogether square for the first 3 terms right here, right? Plus 4, right? Now remember we have the formula antiderivative of du over u squared plus a squared. It's going to be 1 over a arctangent u over a plus c, right? Now this one actually u and a right here is 2, right? Because 2 squared equals 4, right? So this guy turns out to be 1 over 2 arctangent of s plus 3 over 2 evaluated from negative 3 to negative 1, right? So we substitute over here, so we have 1 half arctangent of, substitute negative 1 over here, so it should be 1, right? Minus, substitute negative 3 over here, it should be arctangent of 0, right? So it's going to be 1 half. Arctangent of 1 is actually pi over 4, right? Arctangent of 0 is going to be 0. So the answer is pi over 8. Now question 19. Find the area of the region bounded by the graphs of the equation y equals s plus 5 over s equals 1, s equals 5, and y equals to 0, right? So we're gonna graph this one. It's actually something like this. So the error is the integral from 1 to 5 of s plus 5 over s ds, right? Now we just separate this one, so it could be the integral from 1 to 5 divide this guy by s, so it could be 1 ds plus the integral from 1 to 5 of 5 over s ds, right? So this guy turns out to be s evaluated from 1 to 5 plus bring 5 to the front, and then it's going to be ln absolute value of s evaluated from 1 to 5, right? So this guy turns out to be 5 minus 1, and this guy plus 5 times ln of 5 minus ln of 1, right? So it could be 4 plus 5 ln 5, right? Now question 20. Find the area bounded by the function ls equals 2 power of negative s, the x-axis s equals negative 2 and s equals 1. Now if you graph this one, it's going to be something like this. Alright, so the error is the integral from negative 2 to 1 of 2 to the negative s ds, right? Now we're going to use u substitution, right? So we're going to let u be negative s, and then du equals negative ds, right? and then we need to change the lower limit and upper limit, right? So we have s equals negative 2 and s equals 1. We have u equals 2 and u equals negative 1, right? A becomes negative integral from 2 to negative 1 of 2 to the u du, right? So it could be integral from negative 1 to 2 to the u du, right? So it could be 2 to the u over ln of 2, evaluated from negative 1 to 2, right? 1 over ln of 2 times 2 square minus 2 power of negative 1, right? So it could be 1 over ln of 2, 4 minus 1 half, right? So it could be 7 over 2 times ln 2. Now let's move on to question 21. Let LS be e plus ln s over s squared. Find the average rate of change of this one from s squared 1 to s squared e. Average rate of change is given by the formula f of b minus f of a over b minus a, right? Now this one is a, this one is b, right? So we have f of e minus f of 1 over e minus 1, right? So it could be, now f of e substitutes e for s, so we have e plus ln e over e squared minus e plus ln 1 over 1 squared divided by e minus 1, right? So ln e equals 1, so we have e plus 1 over e squared minus ln 1 equals 0, right? So it could be e left over e minus 1. Now we're going to multiply the top bottom by e squared, right? So we have e plus 1 minus e cubed over e squared times e minus 1, right? 22. Find the error of the region by the graphs of the equation f of s y equals 0, s equals this one, and s equals this one, right? So we have the integral from 2 over root 2 to 2 of 1 over s square root of s squared minus 1 ds, right? This one actually secant of s, right? Evaluated from 2 over root 2 to 2, right? So it could be secant of 2 minus secant of 2 over root 2, right? Now we're going to simplify, so it could be secant of 2 minus secant of root 2, right? Now question 23. Find the error of the regions by the graphs of the equation f of s y equals 0, s equals 0, and s equals 1. Alright, so it's going to be the integral from 0 to 1, right here, right? Of 1 over 1 plus s squared ds, right? So it could be tangent of s evaluated from 0 to 1. It's going to be tangent of 1 minus tangent of 0, right? So it could be pi over 4, right? Now question B. Find the average value of the function f on the interval 0 to 1. So we have the formula. This one you're going to learn in unit 8. It's going to be the average value 1 over b minus a times the integral from a to b of f of s ds, right? So we substitute over there, we have 1 over 1 minus 0, right? The integral from 0 to 1 of 1 over 1 plus s squared ds. Now this guy right here we calculated above is actually pi over 4, right? So it's gonna be 1 times pi over 4. It's gonna be pi over 4, right? Now question C. For what value of s does f of s take on the average value? The average value is pi over 4 right here. And f of s is given by 1 over 1 plus s squared, right? So we just equate this one and this one, right? So we have 1 over 1 plus s squared equals pi over 4, right? Now cross multiply, so this guy turns out to be pi times 1 plus s squared equals 4, right? And 1 plus s squared equals 4 over pi. Then s squared equals 4 over pi minus 1. Take square root both sides, so we have s equals plus and minus square root of 4 over pi minus 1. Since s belongs to the interval 0 to 1, which means s positive, so you only pick s equals square root of 4 over pi minus 1. That's it. Now let's move on to question 24. The number of planktons growing in a controlled research vat is changing at the rate dp over dt equals 1250 over 3 plus 0.15 t. And this guy actually differential equation, right? We're gonna learn in unit 7, where t is measured in weeks. If the initial amount of the plankton t equals 0 is 2400, write an equation that will give the population of the plankton at a time t and use it to find the number of plankton to the nearest whole number after 2 months, which means t equals 8. Because 1 month has 4 weeks, right? So 2 months has 8 weeks, right? T right here is measured in weeks, right? Now we have dB over dt equal this one, right? We just separate the variable, right? So we're gonna multiply both sides by dt. So we have dp equals 1250 over 3 plus 0.15 t dt, right? Now we're gonna take antiderivative both sides, right? So this guy turns out to be p equals antiderivative of 1250 dt over 3 plus 0.15 t, right? Now we're going to use the u substitution, so we're going to let u be 3 plus 0.15 t. So du equals 0.15 dt, right? So then dt equals du divided by 0.15, right? So I substitute over here, I have p equals 1250 divided by 0.15, the antiderivative of du over u, right? So it's going to be 1250 divided by 0.15 ln absolute value of u plus c. But u is equal to this one, right? So I have p equals 1250 over 0.15 ln absolute value of 3 plus 0.15 t plus c. Now we're going to use the initial condition right here to solve for c, right? So we have p right here equals 2400, right? So 2400 equals 1250 divided by 0.15 ln of 3 plus c, right? C equals 2400, subtract 1250 divided by 0.15 ln 3, right? So finally, the formula P is 1250 over 0.15 ln of absolute value of 3 plus 0.15 t plus 2400 minus 1250 over 0.15 ln 3, right? Now we need to calculate value of p when t equals 8. So I have p of 8 equals 1250 over 0.15 ln of 3 plus 0.15 times 8, right? Plus 2400 minus 1250 over 0.15 ln 3, right? Now I'm going to bring up the calculator. I'm going to add calculator, so I'm going to hit the button right here, put the fraction 1250 over 0.15, right, times ln of 3 plus 0.15 times 8 plus 2400 minus fraction 1250 divided by 0.15 times control and button natural log right here 3, and then press enter. The answer is 5203.94, right? But the question wants you to round to the nearest whole number, right? So it could be this number right here, right? So it's gonna be 5024, right? Now let's move on to the next one. Let f of s be an antiderivative of f of s, and f of 1 equals 2. Use the fundamental theorem of calculus and your calculator to find f of 5. Alright, so we have the integral form 1 right here to 5. Alright, so remember the fundamental theorem of calculus is given by the integral from a to b of f of s ds equals capital F of b minus capital F of a, right? Now this one right, now in this situation a is 1 and b is 5, right? So we have the antiderivative. So we have the integral from 1 to 5 of 2 ln s all together square over e to the s equals f of 5 minus f of 1, right? So we have f of 5 is f of 1 plus the integral from 1 to 5 2 ln s all together square over e to the s, right? So we're gonna bring up the calculator. So we're gonna press f of 1 is 2, right? So you have 2 plus, hit button right here, pick the integral right here from 1 to 5 of, pick the fraction right here, 2 ln of s altogether square over e to the s ds, and then press enter. The answer is 2.348, right? Now let's move on to the last one, the review problems from the 2014 AP Calculus AB exams. The following problem. The function f is defined on the closed interval and it's good time to stop. Now let's move on to the AP Calculus AB review problems. This question appeared on the 2014 AP Calculus AB exam. Question 1. The function f is defined on the closed interval -5, 4. The graph of the function f consists of 3 line segments and shown in the figure above. Let the function g be the function defined by g of s equals the integral from -3 to s f of t dt. Find g of 3. Alright, so substitute 3 for s into this equation. We have the integral from -3 to 3 f of t dt, right? So we look at the graph right here, -3 is right here and 3 is right here. Alright, so actually the area of this triangle right here, subtract the area of this triangle right here, right? So the area of this triangle, we have the base is 5, right? The height is 1, 2, 3, 4, right? So 4 times 5 divided by 2, right? And this one, the base is 1, the height is 2, right? Subtract 1 times 2 divided by 2, right? So it could be 10 subtract 1 is going to be 9, right? Question B. On what open intervals contained in -5 to 4 is the graph of g both increasing and concave up? Increasing means g prime of s greater than 0, right? And concave up, which means g double prime of s greater than 0, right? So we're gonna take the derivative of this guy right here, right? So we have g prime of s is, we just substitute s for t into this expression. It's actually f of s, right? And we need this one to be greater than 0, right? So we look at the graph right here. This is the function f, right? So if it's greater than 0, it should be above the x-axis, right? So it should be from -5 to this one right here, 2, right? This guy right here above the axis. So we have the interval from -5 to 2, right? Now next one, g double prime of s is actually f prime of s greater than 0, right? So we look at this interval, f prime of s greater than 0, which means the slope of the line should be positive, right? So we only have this one has a positive slope right here, right? It means from -3 to 0, right? So we have the interval from -3 to 0, right? Now we need to combine this guy and this guy. The final solution should be -3, 0, right? Question C. The function h of s is defined by h of s equals g of s over phi s. We need to find h prime of 3. So we need to take derivative of this one using the quotient rule, right? So h prime of s equals g prime of s times phi s minus phi times g of s over phi s altogether squared, right? So then h prime of 3 is g prime of 3 times phi times 3 is going to be 15, so I put 15 in the front, right? Minus phi times g of 3, right? Over 5 times 3 equals 15 square is going to be 225, right? So we're gonna find the value g prime of 3. Go back over here. G prime of s equals f of s, right? So g prime of 3 is actually f of 3, right? Minus phi g of 3. G of 3 we just calculate right here, right? It's gonna be 9. So times 9 over 225, right? So it could be 15 times f of 3. We look at the graph right here. 3 right here, f of 3 equals -2, right? So it could be minus 2 minus 45 over 225, right? So the answer is -75 over 225, and then it's going to be -1/3, right? Now let's move on to the next question. This one appears on the AP Calculus AB exam 2012. So question 2. Let f be the continuous function defined on the closed interval -4, 3, whose graph consisting of 3 line segments and a semicircle center at the origin is given above. Let g be the function given by g of s equals this one. Find the values of g of 2 and g of -2, right? So we have g of 2 equals the integral from 1 to 2 f of t dt, right? Now the integral from 1 to 2, this one is 1, this one is 2, right? So the error it should be this right triangle, right? But this triangle is below the axis, so it should be negative, right? So it's going to be negative base times height divided by 2. The base right here is 1. The height right here is 1/2, right? So we have 1 times 1/2 divided by 2, right? So it's going to be -1/4, right? Now g of -2 equals the integral from 1 to -2 of f of t dt, right? So we need to switch this one, so it could be negative integral from -2 to 1 of f of t dt, right? Now -2 to 1, this is -2, 1 right here, right? So it could be the error of the right triangle right here. Subtract the error of the semicircle right here, right? So this one, the base is 1, the height is 1, 2, and 3, right? And this one, the radius is 1, right? So we have minus 1 times 3 divided by 2, and the radius of the semicircle is going to be 1, right? So it could be minus pi r, which means 1 square divided by 2, right? So it's going to be -3.5 plus pi over 2, and it's going to be pi minus 3 divided by 2. Now question B. We need to find g prime of negative 3. Alright, so the formula is right here. We have g prime of s actually f of s, right? So g prime of negative 3 actually f of negative 3. F of negative 3 is gonna be right here. It's 2, right? Equals 2. Now g double prime of negative 3 is f prime of negative 3, right? F prime of negative 3, which means the slope of the line at s equals negative 3. The slope is positive, right? So we calculate the slope of this one is going to be rise over run. Rise is 1, 2, run is 1, 2, right? And the slope is positive. It's actually 2 divided by 2, and it's going to be 1, right? Now question C. Find the x-coordinate of each point at which the graph of g has a horizontal tangent line. So if the graph of g has a horizontal tangent line, which means g prime of s must be equal to 0, right? Now we know that g prime of s actually f of s, right? And this guy must be equal to 0, right? So we look at this one right here. It's actually this guy right here and this guy right here, right? This guy is negative 1 and this guy is 1, right? So we have s equals negative 1, s equals 1, right? Then we have g of s has a horizontal tangent line, right? Now for each of these points, determine whether g has a relative minimum, relative maximum, or neither a minimum nor a maximum at the point. Now remember, the function g has a relative minimum when g prime changes sign from negative to positive at this critical number, right? Similarly, relative maximum when g prime changes sign from positive to negative at these critical numbers, right? Now we're gonna check s equals negative 1. So s equals negative 1 right here. We see that the function f of s changes sign from positive to negative, which means going up and then going down. This one is the maximum, right? Similarly, 1 right here, the function does not change sign, right? It's in negative and it's still negative, right? So we only have s equals negative 1. The function g of s has a relative maximum because the function g prime of s changes sign from positive to negative at s equals negative 1, right? At s equals 1, g prime of s does not change sign, right? So the function g of s does not have the relative maximum nor minimum at this point. Now let's move on to the last question, question D. For the interval from negative 4 to 3, find all values of s for which the graph of g has a point of inflection. Alright, so g has a point of inflection when g double prime of s equals 0 or undefined, right? And g double prime of s must change sign, right? So we have G double prime of S is actually F prime of S, right? Now we need to find the value of S where F prime of S equal to 0, right? Now F prime of S is actually the slope of the tangent line of the function f of S, right? So we look at this one is the function f of S, right? Now the slope of the tangent line is equal to 0 when S equal to 0 right here, right? S equal to 0, we have the horizontal tangent line. Remember the Christmas tree trick. The line is going up, the slope is positive. Line is going down, slope is negative. Line is horizontal, the slope is 0. Line is vertical, the slope is undefined. Right? Now we have other two values where the function f is not differentiable, right? It's going to be the sharp turn right here. This guy and this guy right here, right? So right here, s equals -2, and right here, s equals to 1, right? So we have this guy equals 0 when s equals to 0, right? And f prime of s is undefined when s equals -2 and s equal to 1, right? Now we need to check where G double prime of S changes sign, right? So look at this one right here. The line is going up right here, the slope is positive. The line is going down, the slope is negative. So this one changes sign, right? So S equal -2 works. This guy negative and this guy positive, right? So this one works, right? Now this one positive and this one is negative. So this one works, right? So finally, you have the function g has a point of inflection at s equals -2, s equals 0, and s equals 1 because g double prime of s equals f prime of s changes sign at those values. And it's good time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young and it's just begun as she puts her hand in mine.